Greetings everyone. Today we're going to explore writing parallel lines. We do have a note sheet for this, so you'll want to make sure you have access to that. Let's get started. First of all, let's fill in the definition. Parallel lines slope. The definition is that parallel lines have the same slope. They have the same slope. If it's 5, the other line's 5. If the slope is -1/2, the other line's slope is -1/2. Next, let's talk about the parallel lines symbol. The parallel line symbol looks like a set of train tracks, really. It's two thin, tall lines that are next to each other. So this statement could be read as line, there's a line over top, AB, and line CD are parallel to each other. So whatever the line names are, we identify those and we write the two parallel line symbol in the middle. So what is this used for? This is just a shorthand way, instead of writing a long sentence, to say that two lines are parallel. All right, let's look at a variety of examples. First example is from a graph. We want to prove that the two lines are parallel, so we care about their slopes. So let's look at line A first. Oops, let me color match here. So line A is the blue line. It's labeled A. And I'm wondering what its slope is. Well, let's just count. Rise 2, run 2. Oops, careful though. Notice how that scale is missing every odd number. So technically rise 1, 2, 3, 4, run 1, 2. But 4 divided by 2 is just 2. My slope of the blue line is 2. Let's go again, but let's find line B, which is the red line. The red line's slope is rise 1, 2, 3, 4, run 1, 2. So again, I just proved their slopes are equal, so the lines are equal. So we would write it like this, okay? Line A is parallel to line B. Let's try again, but this time we're given sets of points. So we need to review our finding slope between 2 points. Let's start with line 1. Y minus y over x minus x. If you need help with this topic, you want to see my previous videos. -2 over -3, which does simplify to positive 2/3. Let's try our second line. Y minus y over x minus x, a -2 over -3, which a negative divided by a negative is a positive. We just proved that line 1 is parallel to line 2. Let's find the slope of an equation. The first line, y is isolated, so I know that my m value is the number in front of x. If you need help with that topic, you want to see a previous video. The second line, I have work to do. I need to isolate y in order to determine what my slope is. Divide every piece by -2. Y equals +7, +6. If I look at that equation, the value that is my slope is the number in front of x, 6. So we just proved, we're showing that line 1 is parallel to line 2. Let's talk about special parallel lines. So what about lines that don't have a slope? Vertical lines' slope is undefined. So that's unique. So to generalize this, we say that all vertical lines are parallel as long as they have different x-intercepts, right? Meaning they cross x at different points. If two lines are vertical and cross at different values, they are parallel. Now let's apply a little more of what we've been doing to this idea. Let's say I'm given a line and it passes through the point 4, 3. And I'm going to tell you it's parallel to the graph of y equals 7. And the goal is to write an equation of your new line. Now, if you're a visual learner, you could start off with a little sketch, right? If I have the line y equals 7, I slice y at 7, right? That's the line y equals 7. I want my line to go through 4, 3. 1, 2, 3, 4. 1, 2, 3. And I want my line to be parallel to the given line. Oh, so I want it to look like this. I want my line's equation to be y equals 3. Now, how could you do this without a graph? Well, first of all, I think we should use our marker boards to draw a sketch and make sure. But if you are very confident, you could notice this is a horizontal line, so I need a horizontal line. My y value is 3, so my y value is 3. Let's try again. This time, my new line is going to pass through 12, 5, and I want it to be parallel to this line. We want to write the equation of the line in any form. Okay, so here's what I need though, right? Let's narrow this down. I need this point, and I need my slope to be equal. I want it to be parallel to the other one, so I want that slope, meaning I have an m and I have an xy. I don't care about this. That's the other line's y-intercept. I don't need it. So if I'm given a slope and a point, I can just write point-slope form. We've been doing this for a couple weeks now. My y value is 5, my x value is 12. I want the slope 2/3. That's it. It's all you need to do. And since I said any form, you can be done. Let's try again. This one is going to be a little more involved. I'm given a point. I need to use this xy value. And I want it to be parallel to this line, which means I want this line's slope. And I want it to be the same, which means I don't need this. I don't care about that. This time we're going to write the equation in point-slope form and then also slope-intercept form. We've been working on this. So let's start with point-slope form. My y value is -1. I write +1. My x value is -3. I write +3. My slope is 2 because I want it to be parallel. There's PSF. What I need to see and what we need to work on is to get to SIF, I need to see work in the middle. I need to see that you distributed. I need to see that you subtracted 1. If I don't see work, I don't know what you did to get there. Okay, so again, your goal today, use the point, use the slope, write your equation. Just a quick review. Vertical lines, remember vertical lines slice the x-axis at whatever x number they're at. So if I ask you for a parallel line that goes through, I don't know, let's say 2, 1. Well, if it's parallel, it's also vertical through a different x number. So these two lines would be parallel. All right, make sure you check Google Classroom to see what your task is. You're going to be writing parallel lines, meaning you need the same slope. That's the key thing. You need the same slope over and over and over again today. All right, make sure to ask questions, seek out help in the Sabre Center or after school, and until next time, have a good one.